to a distributed SQL database. And we have Timofey Kulin.
Can I start?
Yep. You can start.
Hello. My name is Timofey Kulin. I am a developer, senior developer with more than 10 years experience. And nowadays, my main goals is Postgres compatibility research and YDB driver development. Today, I will talk about YDB and implement Postgres compatibility. 1, 2, check. 1, 2. Do you hear me? Okay. Let's continue. And about some about YDB and about Postgres compatibility implementation. At start, I will give you a short overview about YDB and about YDB internals. Then I talk about Postgres compatibility goals. Then I use advantages and disadvantages of different approaches for Postgres compatibility implementation. And then I will deep in details for YDB way of compatibility. Short story of YDB bond. YDB was started at 2014 as internal infrastructure technology in Yandex. Yandex is a big internet search company in Russia. It handles a lot of data, big data. It handles petabytes of data, and our first adopters moved to YDB, not from usual database, but from special internal big data storages. Next step, and in 2020, YDB was available as managed service in Yandex Cloud. And in 2022, YDB published core sources under Apache 2 license and go to open source world. And at 2023, we start to work for Postgres compatibility. YDB is a wide distributed database, and its main goal is store and serve a lot of data. One table with many petabytes of data is okay. It is normal situation for Yandex, and one server can host a full table. And this means one table can be split and shared between many servers. And one table served by many servers same time. And YDB database can contain a lot of same tables, a lot of big tables. And YDB as a usual database sorry, I'm a little confused. It is my first public talk in English. And YDB guarantees strong consistency for data and any changes made within transactions. Any transaction can contain one or more table, one or more servers. It isn't strictly limited of servers or tables within transaction. It can be any number. How we did it? YDB has base build block is YDB tablet. A tablet is a very light actor. Actor is lightweight user space thread. And YDB tablet is actor with own storage, with local database, stored in high available distributed storage layer. I will not talk about storage layer today in details, but it's used for YDB storage level. Every tablet can handle some specific function. For example, we have tablets for row-oriented data storage, for column-oriented data storage, for message queue, and sometimes some of our users may implement custom tablets. For example, Yandex Cloud is a cloud provider in Russia, implement own tablet for NBS and use YDB for storage layer for network disks for virtual machines. And it works fine. And every tablet handle small piece of data and small piece of load. And YDB scaled by increase tablet count. If table and tablet grow, then can be split. If tablet have limited by size, it can split to twice table, and every of new tablet handle half of data volume. And if some table detected self-overloaded, it can split again, and every new tablet will handle half of workload. Don't size, but workload. And tablet can split again and again and again. Tablet is a very lightweight instance, and one server can host many thousands of tablets same time. It can one tablet and more and more and more. And YDB cluster contains a lot of servers. It can contain many thousands of servers and many millions of tablets. And it works same time. And every tablet handle part of data, part of load, and it is a way for distribute load and storage across full cluster. In big clusters, big clusters with many thousands of computers, computer failure is normal situation. It can be failed disk, failed memory. Sometimes we need to maintain server, and YDB cluster must continue work without interruption. When some server failed, all tablets from the server start at another server. It doesn't need manual intervention from human. It is automatically processed within a few seconds. And YDB cluster continue work without interruption. Let's start about Postgres compatibility. When we published our sources and go to open source world, we want to integrate with the open source world, and we want for our users can reuse rich toolset of open source world of Postgres, and other side we want to reuse our already distributed nature, engine, distributed transactions, strong consistency, what we already have in YDB. And a special point, we want to enable interoperability between Postgres load and YDB native load in same project. It will be much simpler for migrate projects from YDB interface to Postgres interface, and from Postgres interface to YDB interface. For example, most code of project can be written for Postgres because it is usually it is simpler. Much more developers know Postgres. but sometimes maybe 1% of workload must be high optimized, and it can be rewrite for YDB native interface for much more efficiency, for use some special YDB features which can be implemented in Postgres interface. Let's some review of advantages and disadvantages from other approaches for Postgres compatibility implementation. The first, we can implement everything from scratch, similar to CockroachDB. Advantages is it's interesting way, and we can design every function for native integrate within existing code for distributed system. We can optimize every algorithm as we want, but it has disadvantages. We must implement on Postgres features, and we need a lot of work, and we need a lot of work for implement the new features every time when we want to upgrade Postgres compatibility release. And self-implementation, it is a hard way for a mimic for Postgres implementation details in corner cases. Second way, it is get Postgres runtime and switch a storage layer similar to Yugabyte. It has some advantages. For example, it is very good Postgres compatibility because Postgres runtime work itself. And we can use some extensions in Postgres runtime. And it can be relatively easy upgrade Postgres. But it has some disadvantages. Main for us is we will be limited by Postgres runtime. It will be difficult to implement something what don't implement it in Postgres. And it will be difficult to interoperability between Postgres workload and YDB workload. And we need to maintain Postgres fork. And another way is write Postgres extension. It has similar advantages, and we use special extension API, and it will be easy upgrade Postgres release, but we were limited for Postgres runtime and limited by extension points. And next way is YDB way. We take best from two worlds, from Postgres runtime and from YDB runtime. We mixed it. We take Postgres parser for parse query text same way as native Postgres and understand query same as Postgres. But we use YDB query engine for use distributed nature of YDB for distributed optimizer from YDB and able to interoperable between YDB and Postgres. And we use native Postgres function for equal function calculations from Postgres and avoid re-implement all functions. But we use own wire level. I will talk in details in next slides. But it has some disadvantages. At first, it is a lot of work for initial integrate between Postgres and YDB, and moderate upgrades complexity for upgrade Postgres releases. Let's start. At first point, we need to accept TCP connection from a client library by PGWire. Native Postgres fork own process for every TCP connection, and it takes a lot of resources and very limited simultaneously and very limit how much connection one server can handle simultaneously. And we will re-implement PostgreSQL level, re-implement Postgres protocol at own code at async way, and one YDB thread can handle very many Postgres connection, YDB connection, and some other load process query in same process without own actor system. Next step is understand query, parse query. In native Postgres, in native YDB, we parse the query text by YDB parser and create internal query graph for execution. Then send the graph for execute to next level. For Postgres query, we do some similar. We call native Postgres parser, get Postgres AST, then we convert Postgres AST to same internal query graph as native query. And next steps is similar for Postgres query and YDB native query because it is same query graph. And query execution. When query processor receives a query graph, it analyzes it and can optimize the query on that state. It will optimize a native query and Postgres query because them presented with the same format. Then query processor may split a query for a lot of parts and send every part to compute nodes. Many parts of query can be executed same time in parallel. Then compute nodes return results. Query processor combine results and return it to client library. At the point we need to call Postgres function if it exists in query. And for this way, YDB compute node initialize Postgres environment at the compute node and call native Postgres function for calculation. For this point, we need to patch Postgres sources because Postgres implemented as single-thread code and it can't work with multi-thread environment such as YDB. One of most big changes is change global variables for local thread variables. And for every thread, we initialize separate Postgres environment. And we need some settings because before call Postgres function. But Postgres function, think about they called from native Postgres environment and work natively. We implemented some Postgres compatibility, but how we are confident about it is really compatibility? We have some type of tests. At first, we reuse Postgres regression tests. We get Postgres tests and run them for each pull request for main branch. If some of test has new failed, we see it and can fix our code and don't break compatibility in new ways. Second way is documentation test. We copy all of documentation of all functions from Postgres to YDB documentation. And for every PR, we extract examples for call function from documentation, run the query, and check equals between real result and example from documentation. And we can ensure about functions work good and it's work as in documentations. Next type of test is driver integration tests. We create some virtual environments for different drivers. It is a Golang driver, it is Python driver, Java driver, and we run the driver's integration tests over YDB. Fails from the tests can show what need to implement at a low level for wire protocol, for lower level at functions from Postgres, which expected by popular drivers. But all of the tests, it is synthetic tests. They can show some percent of coverage compatibility, but we can't know is it possible to run a real application over this percent of compatibility. And as next step, we take real applications for Postgres, run them, and see for queries. We see what worked good and what failed. And we, from the application runs, we get next step for improve our compatibility. That's all. I will be happy to answer your questions.
When you say Yoga by DB is a distributed nature, right? So when you query some data, like and one table is distributed across multiple nodes. Consider like you have 3-node system, okay, and data is distributed across all the 3 nodes, okay. When I query particular table, is it like all the data come to one place and then you do all the planning on those things, or how does that happen?
Sorry, can you repeat the question slowly?
Yeah, so I have 3-node system. So a cluster having 3 nodes, okay. A gigabyte cluster have 3 nodes, okay, where I'm querying a table which is distributed across these 3 nodes.
Okay. Yes, the query in YDB will distribute across many nodes. It's same nodes. It depends from query. If it is a text for optimizer. For example, if you query for by primary key, the query will send to one compute node for one tablet, which handle the role. If you send some analytic query, it can be distributed across wide nodes for tablets, which handles neat parts of data.
Okay. So my question is like when so I'm writing some analytics queries, and data need to be pulled for all these tablets, right? So it is so is it like data comes to a single node, then the analysis happen, or it individual tablet level this analysis happen, the results comes to the as a result comes. Did you understand my question? So is it like I have querying particular sum of salary of one tape, all employees, right? And each tablet have some employees, which I need to do this average calculation. Is it like I need to pick all the from each nodes? I pick all the data to a single place, then do the average calculation, or in each tablet level the planner do the average calculation and give as the end results of that.
Do I understand your question about if you want some aggregate, will be it calculate on tablets or in query processor?
Correct. Yes.
It will be calculate at a tablet. Then tablet send the state of calculation to query processor, and query processor finish aggregate of results.
So the query processor is a centralized or each individual node level query processor?
Query processor is one of actor in YDB. It work on same nodes as another cluster. It isn't some dedicated server. It's it's part of YDB thread.
Okay. So how do you manage this transaction, distributed transaction, if there is a failure? Because this is a distributed transaction concept, right? So how do you manage those? So is it like a centralized transaction manager who manages this distributed transaction, or how does each individual node do this transaction data? See, it should be ACID compliant, right?
And there I understand question about how we manage transaction, distributed transactions. We have two ways for execute transaction. If we have simple transaction, for example, update one row by primary key, or update some rows from one tablet, it is immediate transaction, and it simple executed by tablet without any additional manage. Because tablet is an actor, it master for part of data, and it knows about all operations with the part of data, and it can apply changes itself without auto manager. But if query need synchronize few tablets or many tablets, for this case we have coordination manager, and it create a plan for transaction. Every tablet at the first step coordinate, take order of transactions from transaction manager, try to apply all transaction itself, and all tablet do it in same order. If all okay and tablet can apply transaction, then coordinator manager send okay, you can apply a transaction for all tablets. But if some tablets report about conflict, in that case, coordinator manager send for tablets signal about the transaction must be failed, and all tablets don't commit changes.
I see. So you use two-phase commit, is it? The protocol. So which protocol you use? The
I don't hear.
Do you use this as a two-phase commit protocol? Is it to manage this type of systems? You use two-phase commit protocol. Is
Sorry,
it?
I don't understand. Can you repeat with other words?
So So my question is, do you use MVCC or this is two-phase commit protocol you use?
Yes, we introduced MVCC in last year,
Okay.
and now YDB use MVCC.
Okay.
And it means about if you have a read-only transaction, it will success always.
Okay. Because as I understood, the Yugabyte, they don't use the storage layer as the vanilla Postgres storage layer. They use basically the RockDB storage layer, right? It's a more appended concepts, right? Basically appended data logs, right? It's a key value pair data, right? Correct?
YDB use own storage layer.
Okay.
It is a blob store. It is own in-house technology for distributed storage. It is KVLS storage, and the storage guarantee about durable of data. And we don't use Postgres level for storage or Postgres logic for storage. We convert Postgres query to internal query graph and execute Postgres queries as a native query and use same storages. From Postgres, we use native types. We store native Postgres types in our storage, and Postgres functions use native Postgres types. And it's possible to handle every type from Postgres for Postgres functions.
So one last question I have related to the Planet side. So if you see Postgres 16 have lot of optimization on the Planet side have done it, but you don't use Planner of Postgres. So how do you going to take those performance impact on those? Because you use native planners, as I understood, Yugabyte's planners are like native planners, right? Is it correct?
Do you ask about what planner we use?
No. My question is, see if you see the Postgres 16 onwards, they have optimized the planner. Planner code has optimized to do some of the joins have optimized some of the things. Okay, so I see like Yugabyte don't use it only use the parsing the query parser of the Postgres. They don't use the planner side.
Yes.
So it is like you don't get the performance what the latest Postgres provide you, right?
Yes, we use Postgres parser, and we don't use Postgres planner.
Correct.
We use YDB native planner for execute query.
Yes.
Now we work about some improvement for better support Postgres style of queries. But we implement it in our planner, and it will be improve and Postgres queries and YDB native queries.
Got it. So basically, you take the planner code of sometime you just refer the Postgres planner code and try to make similarity of that. Is it like that? So, no. My point is like planner have now Postgres planner have like lot of optimization they have done. If you don't exactly like don't make like that, then you will not make exactly like what Postgres have optimized the planner side changes, right?
We don't check equals between Postgres plan and YDB plan because we have very different environments. Postgres planner plan query execution for a single node, but we have wide distributed environment. We have different storage, and for YDB optimized way may be much different from YDB or from Postgres optimized way.
Got it. Okay, thank you. Thank you very much.
Thank you.
Is there any other question? Thank you. Thank you so
Thank you.
much for a wonderful talk.